experts, please report to room A9.
Hello guys, Actor here. Welcome to Rebooting MOS. So, it will start off with this square moving up and in different directions, like so. We can use that in this table to get values which we'll add together. We also have to keep note of the colours here. But first, this will require a bit of colour identification at this part. So, to make it a little easier, submitting through the same number will toggle colourblind mode, just in case you are unable to identify between some of these colours. For example, the green, lime, jade and mint is a classic example of colours that might be indistinguishable. Cream and yellow could also be one, and maybe some of the blues as well. So let's do that first. Hopefully I don't mess this bit up. So we're going to submit on 3 2s. And we're ahead of the cycle for this one then. And then wait for one more 2. And you see it turns on the colourblind mode, but now let's get started with the actual module. So we've got directions and colours here. So the colours we have are cyan, blue, red, and then blue. And the directions is defined by where it ends, so we have top, bottom
Emergency
right,
cleared. All personnel, please return to your stations.
bottom top. Top, bottom right, bottom, top. As you can see here, bottom would be moved from top to bottom. So now we're going to highlight the rows and columns in this table. Of course, remembering if any of them are doubled up, like the T and the on this row and the B on this row, we're going to double them up. So we have cyan and red, which is once, and we have bottom right and bottom, which are once. And I like using the red colouring to show doubled ones, and then green for tripled. And I've never had to use yellow for 4, but that can also happen, I think. So we've got 2 T's and we've got 2 B's. So now we're going to add all these numbers up. So we have 60 plus another 60, because it's highlighted in one set of red, plus 44 plus 54, that's the top row. Then we're going to be having 4 68s because it's highlighted by 2 sets of red highlights. We've got 2 92s, because it highlighted once in red, and 2 99s, plus 2 54s, plus 48, plus 61. Putting this into text field calculator, we'll get 1089. When you receive number by 1000, this is value A, so our value A is actually just going to be 89. Now we're going to be applying these functions to that number to get B. This is very similar to if you've seen Simon Stores. It's similar sort of things. Or 7 is another good example, where you see calculations like so. But first we need to calculate E here. E is the sum of 0 number digits. 8 plus 1 is 9, plus 4 is 13. So our value of E is going to be 13. So, now to calculate B, we had to apply the functions corresponding to the colours we got in the first part. So first we're going to apply the cyan one, where the N is the current step of the sequence, will range from 1 to 4, and then A of N minus 1 is the previous value of N. Well, basically, it could be substituted for an X in other modules, I think. So, we have the previous number multiplied by the stage number, which is 1, so it's going to be still 89, minus e. So, we're just going to have 89 minus 13, which is 76. Then we have the blue function, which is multiplied by the stage number. We are now on stage part 2 of this, so we can multiply this by 2, so we get 152. And you had to do these in the order it's shown. It does matter, even though that's probably obvious. Then we're going to be adding e basically back onto what we just had. So 152 plus e, which is 13, we had 165. And then finally, we have blue again, which is going to be multiplied by the stage number. Remember, the stage number this time is 4. So we get 660. Again, on this one, after each applied operation, so after any of these singular ones are applied, if it goes over 1,000, you have to modulo it then and there. You can't just leave it till the end. So now on 660, we're now going to be calculating the value of C. Add value A and value B to get a single digit and press the standard like when the last digit at the bottom star is equal to that digit. So we have 660 and 89. Adding them together, we get 9 as the last digit. So we'll be pressing the status light when it's a 9. And then we get those colours, and then you can press the status light whenever you want to re-see the colours. So as you see, we were given Maya and cream, which we can find out are the middle one. It's the middle one here and the bottom right one here. So we've got this one and this one. We're given 27 and 14. Using table below, convert these two colours into 6. It's a 6-digit base 3 number, but by taking the components given by RGB here. So the red value of the first colour, which was Maya, is 1. So actually the numbers don't matter here right now. The numbers is what, when we get the final number, we convert it back and then use the number in there rather than the number we get, basically. So we have red values of 1 and 2, green values, which is across the side here. We have the second row here, so this could be 1 again, and this one is the bottom row, so 2 again. And then finally the blue is what section they're in, so this one will have 2, and this one will have 2, and then this one here, this one has 2, this one has 1. Now we can convert both of these combined together, like so. Just to confirm, 1, 1, 2 is our Maya, and 2, 2, 1 is our cream. We're now going to convert this into from base 3 to base 10, or decimal, which we're going to have 1 plus 2 lots of 3, plus 2 lots of 3 squared, plus 2 lots of 3 cubed. Basically, it's going to be 0, 1, 2, 3, 4, 5. So there's 3 to 0, 3 to 1, 3 to 2, 3 to 3, 3 to 4, 3 to 5. So then we're going to be adding 3 to 4 and 3 to 5. We get 403. 403. Multiplied by the last digit of the serial number. The last digit of the serial number is 8, so we're going to have this multiplied by 8. And then we're going to modulo this by 27. we get 11. We're now going to convert 11 back to base 3, which will be... I'm going to try my hardest not to use a converter here. So I'm going to use the method of just subtracting the amounts. So we have 9, 3 and 1, and we can subtract up to 2 of these. Well, we can have one of these 9s. Adding a 3 would make it too big, so we're going to be having 2 of these 1s as well. So it's going to be 201. 201, 102 even. Just to make sure. 3 squared plus 2, 3 to the 0. Yes, is 11. So now we're going to find this number in our table. It's better to go back the other way for this. So for the blue component, it's going to be 2. Blue component is going to be, so we're in this square. The row for green is going to be a top row. And the column for red is going to be the 1. So we've got 89 as our final value. So remember, B was 660. And C was 89. We now know it's 89. This is 1, 0, 2. And now we're going to go to this final multiplication table. Once you calculate those 3, perform an operation to them using the table below. Note, if either of them was 0, make it 1. We're going to be using the last digit 0 number, so that's 8. So we're going to be multiplying all the numbers together for this one. So 89 times 660 plus 89, we get this number. If you calculate value negative, make it positive. This is important. Do not modulo immediately. If it's negative, you have to make it positive first. And if the calculated value is greater than 1,000, we're going to be multiplying by 1,000. So we're going to take this, mod 1,000. You get 860. Those are the 3 digits we're going to be submitting on. And now, on Twitch Places is fine because you can submit immediately. However, it's a bit more scarier when we're trying to do this in real time, so hopefully I can submit this well enough. There's the 8. There's 6. Now we're just looking for the 0. Which I could have got there, but I forgot where the first one appeared. 7, 8, 9, 0. Now we get a cell module. So hopefully you understand how rebooting MOS works. Just some extra stuff. The absolute value will be make X positive, which you can see here. Percentage sign is used as modulo sometimes. And like I said, modulo will not depend on the bottom time if you submit things with Twitch commands. And then you can see the sequences. This square will disappear for a second and reappear to show where the start of the sequence is. But hopefully you understand how to do rebooting MOS now. I'll see you guys in the next tutorial. See you later.